Okay, welcome back. So I will say one thing before we continue. I did mention at the end of the first vector resolution video that all of the three methods should add to the same value. They won't add to the same value because obviously I introduced a random angle for the use of the trigonometry. But the Pythagoras and the scale drawing should add up to the same total value, and that's a good check. Obviously when you're in lesson we can have a look at the answers, and I'll hopefully post the answers on underneath the video as well on YouTube. Okay, so welcome back. Hopefully I haven't scared you too much. So let's look at more difficult kind of vector resolution now. Now this is what's going to start to challenge you, start to see the kind of maths that you're going to do in physics. So we're going to look at other ways of doing it. Now we've done parallel, anti-parallel, and perpendicular. What happens then in the fourth case where they're not perpendicular? So we've got two forces that are not at right angles to each other, and we'll also look at a common mistake that people make when these kind of questions come up. So first of all, let's introduce our two vectors. So we've got a vector there, we will go with 5 newtons, and we've got a vector here, let's make it longer, of 7 newtons. And hopefully you're seeing straight away this is different from the previous circumstance, because you'll be seeing that these are not at right angles to each other. Common mistake here, now this is a mistake, this is not what you should do. Common mistake is people look at these kind of things and then they think, oh, I just need to join it, I just need to draw a right angle triangle with them. Don't do that. Stick to the rule of adding them as you go around clockwise, and you shouldn't go far wrong. You should be able to recognise these when they come up. Don't do this. Some people go like this and they go, okay, that's 7, and they'll draw a right angle triangle out of that. Now that is wrong. That is wrong. It's a common mistake that people make because they think, oh, it must be a right angle triangle because that's the easy thing to do. It's wrong. Okay, don't do it. How we should do these is exactly the same way we did it before. We start with the horizontal, we work our way around clockwise till we come to the next vector and we add it on. So there's our result, and I've already drawn that in. Okay? Now our result is the combination of those two. Now, what I've shown you here is actually the easiest way of approaching these, in my opinion. Scale drawings make these dead easy. However, you do need to be careful because there's something that's missing here. What's missing? Well, it's an angle, because we don't actually know what these angles are here. Now, sometimes they might give you, when they give you the question, they might give you this angle here. In fact, they're probably quite likely to do that because this is a nice tripping point. That means that that angle there, we'll call that A, is that angle here. And so to work out the angle that we really want for the rest of this question, we have to do 180 minus A, because obviously that's 180 degrees, so 180 minus A will equal theta, which is this theta right there. Now that's going to be really, really important because oftentimes that's a nice little extra mark that they require you to do, especially with these kinds of vector resolution. So we're going to give it an angle. We'll give it an angle. Let's call it, again, I like 32 degrees. It's not because it's my age. I'm not that old yet, believe it or not. A lot of white hair, but yeah, anyway, I digress. So we've got 32 degrees here. So 180 minus 32, so that's 150, 148. So 148 degrees right here. So we've got 148 degrees on the inner circle, and we've got two sides. Now, if you've done decent mathematics in GCSE, you might know where to go with this next. You might not. If you don't, this is where you need to pay close attention to this video, because we're starting to cotton onto some maths that, if you're studying maths, this will help as well. And it's a common tripping point for maths students as well. Now I'm just going to rub out some of the working that I've done here because it might confuse you later on. I'm going to rub out the original question as well because we don't need that anymore. So, what's the first thing to do when you've got one of these questions? Well, we need to work out all of the different values that we've got and give them letters. So, we give the angles letters. We give them capital letters, A, B, C. We then give the sides corresponding letters as well. Now the corresponding letter is really important. So A, B, and that's C. Now the reason that I'm just going to rip that out so it looks like 5 meters. So that's C, that's A. Capital A is opposite little a. Capital B is opposite little b. Capital C is opposite little c. So that's how we formed up our triangle. So how do we do this? Well, yes, we guessed it. So the cosine rule. Now the very, very important thing about the cosine rule, it doesn't matter what the letters are. As long as you make the subject what you wanted to find out related to the correct angle later on, it won't make any difference. It won't make any difference. So in this case, we'll stick with this case, a squared is equal to b squared plus c squared minus 2bc cos A. Okay? So here we have a situation where we've got the cosine rule and we've got a lot. Now this is probably one of the biggest equations you've seen so far, and there's lots of terms. But funnily enough, you know everything you need. You know everything, you've got everything. So pretty much straight away, we can just do this algebra to make it square root. B squared plus c squared minus 2bc cos of A. Obviously, in case you weren't aware, I know that during GCSE you might have written times. If there's nothing written in between terms, that just means they've been times together. So you should work all this out. Now, if you're not confident, bear in mind this square root goes across the whole lot here. We just need to plumb in all these numbers. So I'm going to plumb them in so that you can see what I put where and make sure that you can see what I've done. So equals b squared, which is 7 squared, plus c, which is 5, so it's 5 squared, minus 2 times 7 times 5, cos 148. Now, to avoid BODMAS or BIDMAS, whatever you want to call it, doesn't matter, I would recommend, if you're a put everything in the calculator kind of guy or girl, then I would definitely put brackets around those to avoid any errors, okay? Put brackets around those to avoid any BODMAS errors, to make sure that you're doing everything in the right order. So around the times in there too. I'm not going to work this out for you because it'll just be a matter of me plugging these numbers into the calculator. It's something to check when we come into lesson. I will try and put the answers underneath the video as well, but otherwise we'll go through it in lesson. But this is essentially how we deal with non-perpendicular vectors that are at different angles, and we've shown how we add them, we've shown how we use the cosine rule, we've shown how we put all the letters in to make it work, okay? Get practice of this because this is new spec. It wasn't on any old spec OCR material, so you need to know how to do this, okay? Because it's likely to come up because it is new specification material in terms of the mathematics that are required. So whole page spreads of these in your textbook. If you're not confident with these, spend some time with these. Do plenty. I can obviously give you some questions in class as well. okay? We're going to go through in a second, in the next video, how to use this exact same one to work out a missing angle. We're going to use the sine rule. We've done the cosine rule, we're going to use the sine rule. Thanks.